Hello viewers, in today's class we are going to discuss a very important and conceptual limit, right? And in this lecture we'll see how we can evaluate this limit using the concept of indeterminate forms and using the famous L'Hopital's rule, right? So let us start. So viewers, here we have this limit x tends to 0, cos x raised to 1 over x square, right? So here we see that we have a function, the cos of x, which is raised to some power of a function of x, that is 1 over x square, right? So whenever we come across with these kind of limits, we always use the famous L'Hopital's rule, and we'll also use the concept of logarithms, right? So now see, here we have x tends to 0, right? So when x tends to 0, and here we have the function cos of x raised to 1 over x square, right? So if we substitute x is equal to 0 in in these two functions, what we will get, see, cos of 0, and here we have 1 divided by 0 square, and cosine of 0 is 1 because cos 0 is 1, and 1 over 0 square is 1 over 0, that is 1 raised to infinity, right? So 1 divided by 0 is not defined, so we have 1 raised to infinity, and this uh, term or this quantity is known as indeterminate form, right? So whenever we come across with limits in which we get the forms like 0 raised to 0, or we can write infinity to the power 0, and 1 raised to infinity, then these type of indeterminate forms may be evaluated by using the concept of L'Hopital's rule. So here, by taking x is equal to 0 in this function, we get this indeterminate form, 1 raised to infinity, right? So we'll use the L'Hopital's rule, but before applying the L'Hopital's rule, let us take this limit as L, right? And what we will do, we'll take the logarithm of both sides, right? So when we take the logarithm of both sides, what we will get, so we'll have a log of z, that is L, and then we have a limit x tends to 0, and here we have log of cos of x raised to 1 over x square, right? And here we can make use of the property of log, that is log a raised to b is equal to b log a, right? So here we have log of L, that is limit x tends to 0, and we can now write 1 over x square, and here we have log of cos x, right? So we can also write this expression as log of cos x divided by x square, right? And now see, we can also write this expression as limit x tends to 0 f of x divided by g of x, right? So now to apply the concept of L'Hopital's rule to this limit, we have to create the form that is 0 over 0, right? And let us see whether we are getting the form 0 over 0 by taking x is equal to 0 in f of x or the g of x. So here f of x divided by g of x is equal to f of 0. For x is equal to 0, we have f of 0 over z of 0, and f of 0 is log of cos of 0, right? And in the denominator we have 0 square. Now see, log of cos 0. Cos 0 is 1. So here we have 1 and 0 square is simply 0. Log of 1 is 0. That is 0 divided by 0. And here we have this form, right? So once we see that this expression gives us the form 0 over 0, by taking x is equal to 0, we can differentiate f of x and g of x separately, and we can now write limit x tends to 0 f prime of x divided by g prime of x due to the L'Hopital's rule. So now the derivative of f of x, right? F of x is log of cos x, right? So when we differentiate a log of cos x, we get 1 over cos x, because the derivative of log x is 1 over x, and then by chain rule the derivative of cos x is negative of sin x, right? So we get minus tan x, right? Because the sin x over cos x is tan x. So here we have minus tan x, and the derivative of x square is simply 2x, right? So now we can write this limit as minus half limit x tends to 0 and tan x over x, right? And from limits we know that the value of the limit theta tends to 0 tan theta over theta is equal to 1, right? So we have minus half and the value of this limit is 1. So this is minus 1 over 2, right? So viewers, we have log of L is equal to minus 1 over 2, right? Because we have taken the logarithm of both sides, and we have log of L in the left hand side and this limit in the right hand side, and we have evaluated this limit by using the L'Hopital's rule, and we have arrived at this value, that is minus 1 over 2. So log of L is now equal to negative of 1 over 2. So now to get the value of L, which is our limit x tends to 0 cos x raised to 1 over x square, what we will do, we'll take these numbers to the power of e, right? So we'll write e raised to log of L, and here we'll write e raised to minus half, right? And from calculus we know that e raised to log of p is equal to p. So e raised to log of L is simply L, and here we have e raised to minus half, right? That is 1 over e raised to half, that is 1 over square root of e, right? So viewers, the value of this limit is equal to 1 over square root of e, where e is the famous exponential number.